Section 1.7, we are going to talk a little bit about exponents today. We'll talk a lot about exponents next week, but just a little bit about exponents today. And then also about order of operations, and as it applies to exponents, how that works out. So to start with, an exponent. This is the process of repeated multiplication, and it can be represented through the shorthand use of exponents. So when we have a raised to the power n, that means we have a multiplied by itself n times. So on problem number 1, and this is what I expect to see you write down when you get to a problem like this, is that you will write out that this is 3 times 3 times 3 times 3. Okay? I fully recognize that I could just say you're not allowed to use a calculator and force you to do it, but I don't really care if you use a calculator to confirm your answer is correct. I just want to know that you still know how to do it if I asked you to. So you're going to write them all out, and you're multiply. You're welcome to use your calculator at that point to multiply. This one's not too bad because if you pair them up, 3 times 3 is 9, and then 9 times 9 is 81. So my answer is 81. The work you'd show is the 3 times 3 times 3 times 3. Caden?
If it's a negative number inside the parentheses and it's raised to the
Yep.
power,
We're going to do number 2.
do we have to write it out as the negative number?
Yeah, so that's a really good question. I'm going to show you the difference between a couple of things. I know that I have the example here that's number 2. I'll make up another one because I want to show you one other. So if, like you have on number 2, where it's a negative number, so it's negative 2/3 squared, it really means we have negative 2/3 times negative 2/3. You don't necessarily have to have the parentheses. I tend to use parentheses when negative numbers show up. But in that case, of course, this is fraction multiplication, so you're multiplying across the top, multiplying across the bottom. But a negative times a negative is a positive. So this becomes positive 4 on top and positive 9 on bottom. It is important to realize, because whether it comes up today or whether it'll come up later, those parentheses do matter in the original problem. If the original problem had said, let me give you 2 examples and how they would play out differently. If it said negative 6 squared like this, or it said negative 6 squared like this, those are 2 different values. Okay? The fact on this first one that the squared is occurring without the parenthesis actually means that the only thing that's being squared is the 6. So what that really means is there's a negative, yes, but it is the 6 that's being multiplied by itself. When you have the parentheses, it means the entire quantity, negative 6, is being multiplied by itself. So you get negative 6 times negative 6, like that. And that is a really common place for people to make mistakes, is what to do with those negatives there. Because the first one ends up being negative 36, while the second one ends up being a positive 36. I put the positive there just in case to clarify. You don't need to put the positive, of course, but that is a difference. So those parentheses matter in that sense about what's actually being squared. So we're going to talk a little bit about order of operations, and then we'll encompass the order of operations within our exponent kind of problems. So you've probably seen the acronym Pemdas before, right? So sometimes people learn it as Pemdas. Sometimes people learn it as, please excuse my dear Aunt Sally. Okay, so maybe one of those rings a bell to you. It's a little bit of a lie, the way that we have it written down. Let's just identify what each of the letters represents, not as P as in please, but P as in parentheses. And then I'll tell you after we identify them the lie that's present here. So parentheses, what's E stand for? Exponents, which we're now actually talking about. It says M and D, so the M is multiply, or you can say multiplication. And your D is, divide or division. Then we have A and S. So A is addition, and S subtraction. Now, the actual acronym itself very much makes it look like multiplication comes before division and addition comes before subtraction, right? That's what it looks like. That's actually not true. Multiplication and division are the same operation. They can be thought of in exactly the same way, right? If we divide by 2, it's the same as multiplying by 1/2. Whether you remember those details very clearly or not, they are the same. So multiplication and division are actually the same operation. And the same is true for addition and subtraction. So you might remember from working with integers, somebody saying something like, 4 minus 7 is really 4 plus -7, right? It's really addition of a negative. So it's really just addition. So the reason it matters is because when we get to the point in a problem where there's multiple steps of multiplication or division or multiple steps for addition or subtraction, we don't add before we subtract and we don't multiply before we divide. What happens when we get to here is we actually move from left to right. So within this step and within this step, we actually moved from left to right. So if you get to the point where it's a lot of multiplication and divisions, you just multiply from left to right. Lots of addition and subtractions, you add and or subtract from left to right. Okay? So that will sometimes cause people a little bit of grief when they see that because they're simply expecting those letters to really mean there's an ordering. Yes?
So basically what you mean is that if there's like multiplication and division, like just like this multiplication and division, you go left to right. But what if there's like all 4?
Then you do all the multiplication and divisions first.
But if it's just adding
and then you do the addition and subtraction second. So there is still a hierarchy in the fact that you do all your multiplication and division before you do all of your addition and subtraction.
So the only difference is only for multiplication and division.
Yes, right.
I've always been really confused about the rules.
Yeah, and we'll see some examples that'll hopefully clarify some of that processing as we do the examples today. So on our first example, there aren't any parentheses. One other thing that I want to clarify about parentheses, sometimes people think when it says parentheses, it means I need to sort of clear the parentheses out. That may or may not be true. Parentheses actually simply means that you're completing what's inside of the parentheses if you can combine things. You're simply working inside the parentheses first. Sometimes you can't combine the things that are in the parentheses, in which case you move on to the next step, whatever the next step is. So when we encounter them, I'll show you what I mean by that. So in the first one, there aren't any parentheses present, which means if we go down the order of the things that we looked at over here, exponents is second. So the exponent here, 6 squared, is actually the first thing we're going to do. And what is 6 squared? 36. Okay, so we're going to do the exponent step first. And then we have this fraction written, 36, and it's division by -2. So then the only thing that's left to do is division because there's only one step left. And what is 36 divided by -2? Yeah, it's -18. And again, do I recognize that some of you can go from 6 squared over -2 straight to -18? I do recognize that some of you can deal with that, and it's no problem. Show me the in-between step anyway, because it shows me that you've done things in the right order. Okay? On number 2, we see several operations. You see an operation of multiplication, subtraction, division, and addition, right? There's 4 operations. None of them include parentheses or exponents, right? So we're actually on sort of step number 3 here, where we're talking about the divisions and the multiplications. So as we're looking at this problem, moving from left to right, we're just going to do any multiplications or divisions that show themselves there. So I have 6 times 2, and that gives me 12. Yeah, not 6 times 6, not squared, but 6 times 2. So this one's 12. And I'm going to write down the negative sign next, right? And now I have a division step. 16, or even if you want to think of it as -16, that's fine. Divided by 8. That's 2. So the negative is still there. There's my 2. And then I have the addition of the 2 at the end. So this is the step that clears out all the multiplication and division at one time. And then in my next step, I'll move from left to right and clear out any addition or subtraction that's present. So as I move from left to right on this one, 12 minus 2 is 10 plus 2 is 12. So the final result here is 12. About a year ago, I had a previous student of mine. He was a student of mine in calculus, actually, and he's in medical school now. And he actually emailed me a question about order of operations of all things, because it showed up on whatever social media network he was using, and some people were given all sorts of crazy answers. And I don't really know what platforms you guys are on, but it happens quite frequently on Facebook because I'm old. Old people are on Facebook. And you see order of operations stuff, and people screw it up all the time, okay? So this was a medical student, and he sent it to me, and just out of curiosity, wanting to know what is the right answer, because his friends were not getting what he thought it was, and I can't even remember if he was right or not. But this comes up from time to time because people mess it up so frequently. So on the next one, what we actually see not only parentheses but also brackets. Now, parentheses and brackets are still both parentheses, okay? Really what the P in parentheses means is grouping symbols. So there's several kinds of grouping symbols. Parentheses are one, brackets are another. Curly braces, have you ever seen the braces that look like this in a problem? Those are actually another type of grouping symbol. And to be honest, there's a couple more. Absolute values is a grouping symbol, right? There has the additional caveat to it that you have to take the absolute value when you're done. But it groups something together. And then actually your, I don't know if I have an example of it. Yeah, number 6 has a grouping symbol present here as well, because the entire numerator and the entire denominator have to be dealt with separately before you deal with them together. So there's natural grouping there as well that's separating between the numerator and the denominator that you don't always see parentheses on. So on this one, when you do have two sets of grouping symbols here, you start with what's on the innermost piece. So in this case, it's parentheses, and usually it's parentheses they put on the innermost piece. So we're going to start in the very center of the problem with the parentheses that are present, and that's a 7 minus 8. So our first step is going to be to do 7 minus 8, which gives us, nope, negative 1. Negative 1. So we have positive 7 and we have negative 8. Right? I make $7, I spend $8, I've overspent, and now I've got a red in my bank account. But it is a negative 1, like this. And I'm going to go ahead and put back in all of the other pieces that are already there. If you don't want the parentheses around the negative 1, you don't have to have the parentheses there. It's a little awkward to have the plus and then the minus, so you could probably just eliminate writing both of them and write it as minus. So another option here, would be to do this. And just have it written that way too. That would not be a problem. Regardless of whether you have them there or you don't, the parentheses here are not serving the purpose of the parentheses that are talked about in the order of operations. This point, this parentheses really just means I multiply what comes next. So again, we're working from the inside out. There's two operations in here. There's an operation of multiplication, and then there's an operation of addition. So working inside of the bracket, the parentheses, the big parentheses, we still have to follow order of operations. So will I multiply first or will I add first? We will multiply, because multiplication always happens before addition. So I will do this part of the problem first. I need to change that color. It's just not bright enough. Let's try this. It's a little bit better. So the negative 1 times 6 is for sure our operation that we do next. Sorry, I left the 2 off the end. Let me put that in. So negative 1 times 6 is? Negative 6, yes. And again, if you want to keep it in parentheses, you can. If you want to eliminate it now, recognizing that positive and negative, right, is the same as subtraction, you can do that. Whatever makes you feel most comfortable as you're working with that. We're still working inside the bracket because we haven't cleaned everything up, and now we do still have an addition of a negative or a subtraction going on inside. We have 2 minus 6, again, because it's inside the bracketing. Now, I realize there's still two operations here. There's a subtraction and there's a multiplication operation. But the fact that there's still bracket parentheses, right, these brackets, that have something going on inside of them that needs to be cleared up, means that we're still working with the parentheses on this problem. So what is 2 minus 6? Yeah, negative 4. And then I have my times 2. Negative 4 from the 2 minus 6 times 2. At this point, there's only one set of operations left to do. It's the multiplication. And negative 4 times 2 is negative 8. Okay? So do you have to show every single one of those steps? Maybe not, but you need to show something of them. A couple of them in there are necessary. to ensure that you are in fact moving from the inside out, that you do in fact have the correct order going on. Any questions on that one? That one had more going on than the last ones we've done. Okay, how about number 4? What will the first thing we do be?
Exponents.
The exponents, you're right. So my exponent that I see here is 5 squared. 25. So this piece right here is the first piece to work with, and it's a 25. Everything else stays like it was. There is a dot and a 3. There's an addition of the 2 at the beginning. So for what we're doing right now, if you use x's for multiplication, that's okay. If you use dots for multiplication, that's okay. The one caveat to that is if you have a problem that actually has a variable x in it, don't be using x's for multiplication because then it becomes quite confusing. So we're not going to do that. But if the problem has a multiplication symbol that's an x or a dot, that's fine. All right, 2 operations are left here. Which operation am I doing first? The multiplication. So what is 25 times 3? 75. And then I have 2 plus 75, which will give me 77. Okay, is that all right? Let's do a couple that have fractions. Oh, I'm sorry, 5 first, and then a couple that have fractions. All right, so how about this one?
Distribute the exponent.
No, it's very tempting to do.
Is it 2? Like, is it 4? Wait, I
You
don't
gotta do the
know.
addition first.
Okay, which addition, Caden?
It's other part. Yeah. it's other
Yeah,
part.
so it's really tempting to do something with that exponent first. But you have to remember what parentheses means. Anytime I have parentheses that have something going on inside of them to simplify, I have to do that first. So the first operation is actually 7 plus 2, right here. And 7 plus 2 is 9. After that, what will I do?
9 times 9. 9 squared.
Yeah, the 9 squared. I have my exponent to do next. And my exponent 9 squared would give me 81. And then what is 81 divided by 3? Anybody know? Huh? It is 27. Very good, Jacoby. It's 27. Yeah. And you can use your calculator. You don't have to do it in your head. It's okay. It's 27. I would like to mention that I chose this one on purpose because one of the things that you guys talked about squaring first is a very common mistake. I want to show you what happens if you try to square each of the individual pieces before you actually add them together. So if you actually try to do a distribution kind of an idea here, I'd like you to see what happens. 7 squared and 4 squared is what you would be attempting to tell me would be true. What's 7 squared? 49. And what's 4 squared? 16. Is 49 plus 16 81? It's not. So this idea of distributing across the parentheses when there's addition actually doesn't even work at all. It will work if there's multiplication inside only, but it doesn't work at all if there's addition inside. Okay? It's very tempting to do. This is one of the mistakes that are very common, but it doesn't work. So this is...
You only distribute the exponent when it's multiplication?
Yeah, if it's multiplication, you can. Yeah, and we'll actually have that as one of our properties of exponents when we talk on Tuesday. Yep, there is a distribution across multiplication, but not across addition or subtraction. Number 6. Okay, so I mentioned number 6 a little bit ago as having some sort of inherent grouping symbols that are not actually drawn in. Now, there's definitely some grouping symbols in the bottom that are drawn in, right? Yeah, you see the symbols on the bottom. There's parentheses. But there are no grouping symbols on the top. However, we still need to simplify the entire top and simplify the entire bottom before we simplify between them. So whether you see them there or not, there are understood grouping symbols right here. We got to do everything on top before we compare it to what's on bottom and do any simplification. So let's actually start with the top, just because I've been mentioning it. There are 2 operations present on the top. What operation will I do first? Multiplication. So that's the 4 or the negative 4 times 3, right? So no, it's not negative. It's actually positive here. Sorry. So what is 4 times 3? 12. So the top is actually 8 plus 12. Now, I can still work on the bottom independently and continue this process. I don't necessarily have to rewrite the denominator and not do anything with it. But I won't do anything between the top and the bottom until I've simplified them individually. So on the bottom, I have two operations. What will I do first? It's actually subtraction because the parentheses, right? So 6 minus 2 is 4. So the denominator is now 4 squared. On the top, I have 8 plus 12. Let me move that up just a little bit. Yep, that's 20. My denominator is 4 squared, 16. So at this point, we've simplified everything there is to simplify on top and everything there is to simplify on bottom, right? So this is the first time when I'm actually able to do any simplification between the top and the bottom. And we've talked about fractions a fair bit already in this class. But you can't do any simplification with those fractions until it's a single term on top and a single term on bottom, which it is now. So 20 and 16, they're both divisible by 4. So if you want to write that divisible by 4, you can do it that way. If what you want to do is simply to mark the 20 out and the 16 out and just do the division by 4, that's fine too. Regardless, what is 20 divided by 4? It is 5. And 16 divided by 4 is 4. And you're stopped there. Now, we talked about mixed numbers a little bit, but unless the problem specifically tells you to put it in mixed number form, there's no request for you to do so. This would simply be 5 over 4. Any questions on that one? All right, let's consider another one. I think it has fractions as well. Yep, one more with fractions. Okay, so what would we do first in this problem? Yeah, there's really only two operations that show up. I have addition here and I have a multiplication here, so I'll do my multiplication first. If you wish, you can cancel along the diagonals. We've talked about that. This 6 and the 4 actually have something in common. They're both divisible by 2. So 6 divided by 2 is 3, and 4 divided by 2 is 2. Okay, if you don't want to do that right here and you want to simplify it at the end, that's fine too. It won't hurt anything. For right now, all I'm going to do is to rewrite the 1/5 at the beginning and the addition sign in between. And then we're going to multiply straight across. So 3 times 1 is 3. And then on the bottom, I have 5 times 2, which is 10. Okay, so we definitely did the order of operations in the right order. We multiplied before we added. There's only one step left, though. It's addition. And we've talked about what we have to do in order to have addition to work out. What's the important feature to remember? Yeah, got to get a common denominator, right? So what could I do to make these denominators the same? There's more than one answer, but what is something I could do? Yeah, not 5, but 2. So I can multiply by 2 on the top and bottom of the first fraction, because 2 times 5 is 10. So on the first one, I get 2 over 10. The second one was already 3 over 10. 2 over 10 plus 3 over 10 is 5 over 10. Careful, make sure you're adding and not multiplying. 6, it's not 6, it's 5. 5 over 10. And then you need to simplify. You're right. We always are going to simplify the answer at the end. 5 over 10 is the same as 1/2. Or you can say, hey, look, these will both divide by 5. You don't have to write this down, but that is where we're getting the 1/2 from. They both divide by 5, leaving us with 1/2. Indeed. Any questions on that one? Okay, one final example before we get started on work. What operations do you see present here? Okay, there's parentheses, but
Division and subtraction.
yeah, there's really just two operations, division and subtraction. Is that what you're going to say?
Distribute the negative.
You can if you wish. So you can recognize this as a -1, kind of like you're multiplying. And you can do that. So yeah, you could, if you wanted to, go ahead and recognize that that's a negative times a negative is going to be positive. I'd like to show you what happens if you don't do that, just so you can see that it'll all work itself out eventually anyway. There are parentheses, like Haven mentioned, but the parentheses here don't serve the purpose that parentheses do in the order of operations. Because the only thing inside the parentheses is a single digit, right? Single number, rather. Yeah? There's nothing to simplify inside the parentheses. So if we're looking at order of operations here, the first order of operations to deal with, besides the fact that I could deal with the negatives, is that there's division. Right? There's subtraction right here, and there's division. So what is negative 44 divided by 11? It is negative 4. So that's the part I'm going to do first, not because I have to, but just because I want to show you. If you do that part first, you still, at this point, end up with that negative to deal with. Okay? So whether you dealt with it at the beginning or whether you choose to deal with it now, either place you're going to deal with it, you're going to end up with a positives. Okay? The opposite of a negative is a positive. So we end up with 6 plus 4, which is 10. If you had done it over here, we would have had, what are my numbers? 6, and you would have had a plus here. You'd have had your 44 divided by 11. You still would have done the 44 divided by 11, and you would have had 6 plus 4 here to give you 10. Okay, so those are two different ways that could show up on your paper. Okay, any questions? All right.